Hey guys, this is an Anycast address. What I've done here is this is a IPv6 network. These are two FTP servers. These are very important FTP servers. They serve files through FTP to this company's employees. So it's very important that all the files are always available. So with Anycast, this is what we can do. We can assign an Anycast addresses to these two servers. OSPF is running on this network, by the way. Once we're done configuring the Anycast addresses, the OSPF will forward packets from these PCs to the nearest server in terms of OSPF cost, of course. Let me go ahead and configure it, and you'll see what I mean. Here we go. We said in the blog that all an Anycast address is an IPv6 address, either global or unique address assigned twice to two different interfaces. And that's what we're going to do. 0, we're gonna say IPv6 address FD00 column. Let's do column 1 0/127. And this is a key point here. If we do see here, it says Anycast. It is not necessary to put in this keyword here, but what this keyword does, Anycast, is tells this interface, or actually tells the process that this is an Anycast address, of course, and what it does is turn off duplicate address detection. This is an intranet. We don't know what's in here, but it all belongs to the same company. So we're gonna say Anycast, enter. We're gonna go into the server, and we're gonna assign an IP address, IPv6 address. Oops, wait a minute. Here we go. IPv6 address. There we go. Let's say FD00 column 0. We have one on the other side on the router. 127 FD00 column 1. No, I think I said the other way around, isn't it? Wait a minute, let me check. 0. I said 0 here, so we're gonna say 1 here. There we go, and this is it. Now we're going to ping, see if we can get a response there. Ping FD00 column, and we got a reply. So we just configure an IP address here, There is communication here in this link from point to point. Now we're gonna see if OSPF is distributing the new network. Let's say enable. Oops. Wait a minute. Enable show IPv6 route. I don't see it. Do you? 5, 4, 3, 2, 2, 1, 1, 1, 1, 1. If all zeros, let's do it again. Oh, wait a minute. See, that's one thing. We're never gonna see that. I haven't. Did I? No, I haven't enabled OSPF on fast Ethernet 0/0. So I'm gonna do that now. Let's say IPv6 OSPF 100 area 1. Now we have this interface participating in OSPF. Let's see if we can see it now. More. Here we go. Oh, this is local. Wait a minute. Here we go. Here we go. And as you can see here, it has a cost, an OSPF cost of 3. Now we're gonna do the same thing here in this server. We're gonna assign the same IPv6 addresses. Let me see if I can get it in the. Here we go. We're gonna say FD00 column 1 127 FD00 column. Same as before. And now we're gonna assign the IP address here. Wait a minute. Enable conf t interface fast internet /0, and we're going to say IPv6 address FD00 column /127 Anycast. We're gonna do a do ping FD00 column 1, and we have communication. So now we have assigned IP addresses to the server and also to the router. I forgot to include that interface on the OSPF routing session. Here we go. Wait a minute. IPv6 OSPF 100 area 1. Done. There we go. It has the same. It hasn't found the other one. So this is what we're going to do. Let me show you where the ping goes. If I want to ping from this PC, we should be able to do so. Wait a minute. Here we go. Ping FD00 column 1. Remember that we have FD00 column 1 assigned to this server and also to this server here. Same IP addresses on both servers. So we're gonna hit enter, and as you can see, it pings. But now we're gonna see where it goes. That's not it. I always confuse it with. Yeah, it's trace or T FD00 column 1, and as you can see, it goes 1, which is the local network here, and then it goes 2, 3. So we're gonna see here. There we go. 1 is here, 2 is here, and 3 is here. So it's going to this server right here. Let's see if we can see it in action. Let's do it again. This time we're gonna see the little package out of that. Let me do a ping. FD. I think I have it here. Should I? Don't I? Here we go. Now we do a ping. Let me reset the simulation and let's do this again. Ping. Here we go. Now we're gonna see the little packet fly all the way up to this server here. There we go. Here we go. Here we go. Here we go. Now, let's assume, or let's think about this for a moment. Both servers are up and running. Both servers have an Anycast IPv6 address assigned to them, the same address. That makes it an Anycast address. But it's going into this router here, not the one at the bottom, with a cost of 3. What I'm going to do now is simulate that this. Let me go back to real time. I'm going to simulate this server being down. I'm going to shut it off, and we're going to see where the ping goes, or what server is chosen. Well, there's only one other server, so it's going to go to that one. But we're going to see how that's done. Wait a minute. Physical. Zoom out. Turn off. I just turn it off. It's off. Let's do show route, see what shows here. Here we go. Look at this. I already took the other one. Same thing here. However, it's no longer a 3. It's a 4 now. That's why it chose this route first, because it had a lower cost value. We don't know what's in here. So I'm sure there's an extra jump in there. An extra hop actually in there that makes it an extra hop going over this way, not this way. That's why it shows this one with a lower cost of 3, and now it shows this one with a lower with a cost of 4. We're gonna repeat the same commands. First, we're gonna make sure that it's responding. It is responding. We already know that this one is responding, not this one, because this one is off, so it's gotta be that one. And now we're gonna do a trace route to the same IP address, and this time instead of taking 3, and here we have our extra route. Remember before? Look at this. Can I go up with this? Oh, here we go. When we did it before, where is it at? Here we go. It went from 1, the local network, over to 2, and then to 3. Now, let me run it all the way down here. Now it goes 1, 2, no longer 3, it goes down to a 4. That is the extra hop that we see in the cloud, and then 5, which is this one here. And we're gonna see it by doing a ping. Here we go. Let's see the little packet go there, 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 and now it's gonna go down. Oh, see, it jumps to, and it does the other hop, and now it's gonna go down. So now, if I bring this server up, everything will the routing protocol OSPF will select that path instead of the other one because it has a lower cost. Let's go ahead and turn it on. Wait a minute. Zoom out. Turn on. Let's see how long it takes for it to pick up on that. It already did. No longer a 4, it's a 3. We're gonna do a trace route again, and we're gonna see our 3 network appearing on the trace packet. Wait a minute. Let me do it again. 2, 3. There we go. That is an Anycast address. We have this fault tolerance. That's what it does. That's what I'm trying to say. Okay, I think that demonstrates what an Anycast IPv6 address is. Thanks for watching.